So now we're going to have a conversation with Reid. Reid is a longtime tech entrepreneur. He exited the industry and then got to reading, writing, thinking. He wrote a best-selling New York Times book. The name is After On. He has his own podcast, which is actually quite interesting, and it's about mostly focuses on the future and building the future. He has also been reading, writing, and talking a lot about the greatest risks to humanity. And specifically, he's done that about pandemics. Now, at the Oslo Freedom Forum, we like to mix things up a little and provide fresh and different perspectives to the communities that we serve. And this conversation we're going to have, it really was something that was born out of a talk I heard him give in Vancouver last year. This was one of the most terrifying talks I've ever heard anyone give. And yet it was a masterpiece. It was very, very dark. But sometimes listening to something dark is necessary because the message that is contained in it is something that people need to hear. And it was a lot of bad news. So Rob, this is really what you're here for. You discussed in that talk, what would happen if someone who was apocalyptic and had an interest in engaging in suicidal mass murder would hitch a ride on the field of synthetic biology. And this may not seem related to people, to the current pandemic, but we're going to build toward that. And I think it's very important to that. Now, you were talking in that talk you gave in Vancouver about that.
Yeah, so I think there's kind of a core dynamic. A certain percentage of people out in the world, for whatever reason, get to a point in their lives, get to a point in their psychology, where they're inclined to not only end their own lives, but to do so in the act of killing as many people as they possibly can. There's roughly one mass shooting per day in the United States. Not all of those people are suicidal, but a very significant percentage of them are. And there are some more dramatic acts of suicidal mass murder just in the past few years to commercial pilots deliberately down their planes, killing everybody on board. So of the 800,000-ish people who tragically end their own lives each year, a tiny, tiny percentage are in this category. You think of that as being a circle in a Venn diagram.
But those folks don't have the power to annihilate humanity.
Almost nobody, well, nobody did for most of our history. Then, with the advent of the Cold War, roughly two people, and I say roughly because they had aides and other people who might have been able to grab the red button. For most of the adult...
By that you mean, by red button, you mean the premier of Russia and the president of the United States.
Yeah.
So they arguably had the power to end humanity.
Yeah, Kennedy, Khrushchev, Brezhnev, Nixon, Reagan, Gorbachev, pick your pair. But that was a pretty wrenching development in human history. That was something that had never happened before, obviously. And it was a very, very big development geopolitically and also psychologically, that all of a sudden two people could hit that red button. But these were pretty level-headed people who had come to the top of the American and Soviet systems. And those types of people tend to have different motivations, different levels of emotional stability than people who engage in suicidal mass murder. So we got through the Cold War. Now, the trouble is, we're entering a period in which a lot more than two people will potentially have the ability to wield apocalyptic power. So imagine a simple Venn diagram with two circles that don't intersect. In one circle are those people who could cause an apocalypse if they were so inclined. Usually, most of human history, 0 people, then 2 people. That circle is growing, and we'll talk about why in a moment. Then there's another circle, a much larger circle of indeterminate size, which is those people who would very much like to kill as many people as possible, perhaps including all of us if they only had the chance. We don't know what that number of people is, but there's certainly enough people in that circle to, commit one mass shooting per day in the United States and other acts of profound violence throughout the world, not all of which are suicidal, but some of them are. We really have to worry if those circles ever intersect. Now, they're going to intersect if they both start to grow a great deal. Let's assume the circle of people who are suicidal mass murderers or suicidal mass murderers in waiting is a static circle. It's not growing, but it's probably a constant size, a constant group of people across societies, across history, and so forth. I believe that the group of people who are in a position to exercise apocalyptic powers is growing. And should those circles intersect, should somebody who is inclined to end it all and take as many people as possible actually have profound apocalyptic powers, we're in trouble.
Now, in your particular case, you are concerned about synthetic biology, a field that has the potential to solve so many of humankind's problems, that can fix so much hurt in the medical field, health. It can do so much to our benefit. Yet you are particularly concerned that synthetic biology is exponential nature and its availability is something that we should be, frankly, very, very concerned about.
Yeah, so just start with a quick definition. Synthetic biology is often abbreviated as synbio. I might use that shorthand myself. Involves the creation of completely novel forms of life or non-life. Viruses are technically not living creatures. Things that haven't and probably never would arise in nature. Creating them by artificial means, usually by modifying DNA or RNA. And as you mentioned, it has unbelievable promise. I think synbio is going to help us cure cancer, solve a lot of ecological harms, extend longevity, lots of other great things. But it is also something that, like commercial planes, which have been used for horrible uses, it's a dual-use technology, and that malevolent actors could hijack it and do things that cause incredible harm. And also, as you mentioned, it's an exponential technology, which means that the raw power that's available to the people who practice synbio doubles with great rapidity and great regularity, roughly every couple of years. And our brains aren't really well configured to fathom what happens and how fast it happens with exponential processes, because it's not something that happened on the savannah when our ancestors were growing up. In the case of synthetic biology, I'll use one example. Technically, it's not synthetic biology, it's raw biology. It uses the same technologies, which is the Human Genome Project. So the Human Genome Project took about 13 years. It cost over $3 billion, and it involved the deep engagement of thousands of great scientists, some of our best biologists. And in the process of that, they read the base pairs, they read the DNA letters, and a single human genome, Human Genome Project. Today, that same feat can be accomplished in a few hours for a few $100s by a talented lab tech who may or may not be a college graduate. So that's almost an unfathomable level of improvement. And that level of improvement, that level of advance is going to continue in this field of synthetic biology. And that doubling that has enabled that, I mean, this is what, a 5 millionx improvement in price performance. That's going to continue as well.
So what you're positing is that someone can take a virus and alter it and then allow it to go into humanity. I remember in your talk, you talked about H5N1. This was a not a very contagious kind of flu, where a group of researchers at labs in the United States and in Europe were nerdying around with it and deciding to alter it somewhat. And they turned it into something that was highly contagious and apparently very, very problematic, very, very deadly. You quoted in your talk Science Magazine, and I'm going to read the quotation here. And it says, Science Magazine said, with regard to this virus that they were playing around with, H5N1, if it were released, it would trigger an influenza pandemic, quite possibly with many millions of deaths. Now, Science Magazine could have been describing the coronavirus.
Yeah, and they were actually describing could have been, because obviously that is having an impact on that scale. In fact, they were describing something that's a hell of a lot more terrifying. So let me tell you a little bit about H5N1. H5N1, in its natural form, frankly makes coronavirus look kind of cuddly. Coronavirus kills something less than 1% of its victims. That's the current estimate. We don't know how much less. We don't really know the denominator, the number of total carriers out there, but it's probably less than 1%. H5N1 kills 60%, 6-0. So 50 to 100, maybe several hundred times as many people as coronavirus. However, it's not very contagious. In fact, it's barely contagious. It's probably killed fewer than 50 people in the last 5 years. what these researchers did, and this was in 2011, a long time ago, two different teams, one in Wisconsin, one in Holland. What they did is that they modified this virus to make it as contagious as chickenpox or measles, which is to say radically more contagious than COVID. Now, these were not bad guys. These were virologists. They were doing it because they wanted to understand the nature of viral genomes and so forth. But the fact is they created something that could probably kill, frankly, billions of people if it got out there, because its level of contagiousness is completely off the charts. And it's being applied to a disease that is pretty much as deadly as anything that's out there. It's even more deadly than Ebola. Now, they did this in 2011, and that's really important to that. Because since 2011, the tools that are available to anybody practicing synthetic biology have doubled in capability and doubled and doubled.
But I must interrupt you, Rob.
Yeah, please.
I mean, they were playing with this, and then they were told, stop this immediately.
No, they weren't told that at all. They were actually no.
Where is this virus living? Where is the architecture of this virus living?
Probably in some cryogenic fridge someplace, perhaps alive and well in a petri dish in a level 4 biosafety lab. Certainly the genetic modifications that were applied to that virus, I think that the H5N1 genome is fewer than 10,000 letters, which is not very long. There's a lot more data in your earliest and lowest fidelity cell, right? And the number of modifications that were made to that genome might even fit on a Post-it note, okay? So this virus is two things. It's an organism that can replicate and kill people if it's thawed and out in the wild, but it's also a data file with 10,000-ish letters in it. And there's no question that those letters were recorded, and they sit on the hard drives of the researchers and maybe on other hard drives of certain trusted people. We know that hard drives can get hacked. You know, if the three companies that are responsible, one of the three companies that's responsible for credit ratings can have itself completely hacked, it doesn't defy reason that a researcher at the University of Wisconsin could have his or her hard drive hacked. So this was generated again also in 2011. Anything by definition that was possible in 2011 in biology is radically simpler today. It's cheaper, and much more significantly, in my mind, the number of people who are capable of any particular feat in life sciences in 2011 has radically expanded because the technology has become so much more powerful and so much more widespread and so much more affordable. Now, back in 2011, that was before we even had CRISPR, which is something that probably a lot of viewers have heard of, which is an unbelievably powerful system for editing DNA, RNA, nucleic acid in general, which basically came on the scene just a few years ago. And the advent of CRISPR alone would make acts like that radically easier than they used to be. And you'd asked if they had been banned or shut down. The answer is no. That form of research temporarily lost its funding. It's called gain-of-function research, which basically involves gain of function. Make this virus way more contagious. Make this entity way more something. And generally, gain of function tends to imply things that become more dangerous. There was a temporary halt put on gain of function research after the outcry that resulted from this. And that halt actually was finally ceased, I think just a few months ago. And it wasn't a ban on the research. It just said, the government's just not going to fund this research. If you want to do it all you want. It's just not on our dime. And once again, that ban was temporary and was very recently lifted.
Now, is a doomsday bug possible to create? From what you're telling me with regard to CRISPR, it is very possible to create a doomsday bug. And if so, how much worse would it be than COVID? And if you want to use H5N1 as an example, if you want to think of that as a doomsday bug, please do. But tell us.
Yeah, I mean, I think it's possible to do it because it's already been done. It's hard for me to even conceive of something more terrifying than the H5N1 that was described in the journal Science, which, in case folks don't know, that's one of the two top scientific journals in the world. And so this chart that we're looking at here, this was originally in the New York Times with one slight modification that I'll talk about in a second. It's in the Times about a month, maybe a month and a half ago. And on the x-axis, it basically shows how infectious a disease is, how contagious it is. And on the y-axis, the up and down axis, it shows how deadly it is. And these are logarithmic scales. So if something is way at the top, it is profoundly more deadly than something that's at 0.1. So you see seasonal flu at the bottom, bird flu at the top. Bird flu isn't 5 times more deadly. It's like 500 times more deadly than seasonal flu. So any movement on either axis on this chart is pretty terrifying. The pink triangle that you see, it says new coronavirus. That was before it was named COVID. There was uncertainty then, which has tightened up a little bit, but we still have uncertainty about exactly how deadly it is and exactly how contagious it is. But somewhere in that pink triangle is the dot that represents how overall terrifying COVID is. Now, you'll see in this chart, there are very, very deadly diseases that aren't terribly contagious, like Ebola, up there at the top left. And there are very, very contagious diseases that aren't as deadly, like chickenpox down on the bottom axis, or a little bit further up, measles. There's nothing in that upper right quadrant, or at least there wasn't until 2011, when these researchers went to work and created this new modified version of H5N1. So the one dot that I added to this New York Times chart is there in the upper right corner. It shows where, at least as described in the journal Science, H5N1 lives. It is so completely beyond the frame of reference of any disease that has ever blighted humanity, at least in modern times, that we simply have no frame of reference for it. So therefore I say yes, this was created in 2011. Therefore, it is absolutely possible to create a doomsday bug. And one thing you'll often hear very responsible, very smart, very well-meaning virologists and epidemiologists saying, they'll often dismiss the possibility of a doomsday bug ever being made, because they'll say, you know what, to create something like that from the ground up, viruses are far more complex than people think. Bacteria are far more complex still. To create all that metabolism and write that from raw genetic code, it's unbelievably difficult. It's science fiction. Don't worry your pretty little heads. And I think these people say it for the right reasons and come from the right place, but you don't have to write it from the ground up. You can start with something that is unbelievably close to being a doomsday bug and make relatively simple modifications to make it a little more deadly, a little more contagious. I'm not saying it's something an 8th grade kid can do with a home science kit, but it is something that smart people did in 2011 already.
Okay, so how do we stop this from happening? Because it would seem that if scientists were allowed to mess around with H5N1 to make it far more deadly, make it so deadly that it could wipe out most of humanity, I have to ask, why? What was the scientific purpose behind that? And why should they have a right to play around with biology in a way that could, if they had an accident, caused untold millions of deaths?
Well, I don't personally know these virologists, and I never saw them answer those questions in the press. I would imagine they would say, hey, we're virologists. Our job is to understand viruses. And this is a plausible virus, and by engineering it, we understand it better or something. I don't want to put words into their mouth. But there was a backlash against the backlash. A lot of people said, how dare you try to censor scientists? Scientists get to do whatever they want. And it's an outrage that data function funding is being paused. I mean, there was a hearty debate that ensued. Mm-hmm. And so some people would argue that scientists should get to practice whatever science they want because information wants to be. I don't want to put words in. Now, the question that you asked, how can we stop this? I think it'd be very, very difficult to do so because there are hundreds of jurisdictions in this world, different national governments, some of them more benign and some of them more malevolent. And if the benign ones all said, you know what, let's put a stop on all synthetic biology research or even this particular flavor of it, the malevolent ones are going to just keep carrying the ball. They're going to go forward at full steam. And next thing you know, you've given Kim Jong-un a monopoly, perhaps on something really terrifying.
So then how can this research be transparent while at the same time safeguarding the top secret nature of something like what we are doing in this lab is studying something that is extremely dangerous, and if it leaked out, it would kill half of humanity? How does one do that? How does one make sure that the public is protected?
Well, the only ways that I think could reliably make sure things don't happen that could potentially go awry would ultimately mean this is not creating a nuclear weapon. I mean, thank God, creating a nuclear weapon still requires the resources of a nation state, and it can't be done in a garage. This is exponential technology that is getting faster and faster and cheaper, and therefore, by definition, will be practicable in garages. In fact, it already is. It's just that what can happen in a garage is going to get awesomely powerful with extreme rapidity. The only way to stop things from happening in 200 million garages, the United States as an example, is an unbelievably intrusive surveillance regime, which this country doesn't want to sign up for, and which I know you certainly would not advocate.
Right. Absolutely not. No, out of the question.
So precluding any kind of science that could potentially be bad is not something that can credibly be practiced in open society. So let's leave that aside, just as something that's impractical and to many minds completely undesirable. What I think you need to do instead is to envision, to have the imagination of what could go wrong, to go to the very, very dark places that we don't generally want our minds to go, and think about what could go wrong and what makes it tricky. So you need to think about what could go wrong in 7 years and 14 years, going down an exponential curve. And that is very, very difficult. Our imaginations are not configured to think that way, and anybody who doubts that need only look at the opening weeks of the COVID crisis and see all the dismal mistakes in retrospect that a lot of public health leaders made because they didn't really fully fathom how fast an exponential process can travel. So we need to think very hard and very darkly and very imaginatively about what could realistically go wrong with 7 years, 10, 14 years doubling of these curves, and start creating a global immune system to detect and subvert any pathogen that a malevolent actor could put out there. And by the way, a great side effect of this is we'll get really, really good at detecting natural pathogens like the next COVID, like the next flu, et cetera. There's all kinds of benefits that can come from this. But
so you're saying like an early warning system, which leads me to a question specifically about coronavirus. What does our response to coronavirus tell you about our lack of preparedness?
That it's almost boundless, and that our imaginations did not go to basically a very slow motion train that was trundling toward us at walking pace for years and years and years, and was warned about by people like Bill Gates from the TED stage 5 years ago. It was a complete failure of imagination, a complete failure of preparation, and one of, perhaps the silver linings of this horrible period that we're going through right now may be that people start realizing that this kind of thing is not only possible, but it's inevitable. And I do hope that people push their imaginations to think about something far, far, far more catastrophic than COVID. Because if something ever is engineered with malevolent intent, it's going to make COVID look trivial.
Look trivial, you say?
Absolutely. And then, by the way, that's one reason why I personally don't think there's any possibility that COVID was an engineered pathogen. If somebody really wanted to get evil, they would have created something that is far beyond what we're dealing with right now.
Yes. I mean, well, the discussion about whether this was leaked from a lab deliberately or by accident, or whether it was actually magically, brought from some bat 1,000 miles away that was eaten by that's a discussion that I think it's too premature to have with the evidence at play. But I'm sure that it's something that we will either get to the bottom of, or will be the subject of conspiracy theories for years to come.
Absolutely. But the important thing is, I think of a global immune system as having potentially, 4 or 5. I can think of 5-ish prongs to it. I'm not a scientist. Smarter people can think of more prongs to it. But we need to start developing it now. We can't wait 5 years, knowing that this is at least 10 years off. Let's wait the first 5 years. That's insane. You cannot get ahead of an exponential curve, as we've learned from COVID, by pausing for a great deal of time. So I hope we start building something rapidly and putting the R&D dollars in lots and lots of different pockets, the way that we do with national health dollars and other things. And basically, the 5 pieces that I see it consisting of would be pathogen detection. We can talk about any of these in detail. But pathogen detection, vaccine creation at the edge. So not a system where all the vaccines are made in slow motion in Atlanta and gradually shipped throughout the country, or made in various places and shipped throughout the world, but are made on the spot where they need to be consumed, ideally in every pharmacy, doctor's office, maybe eventually in every vendor. That's the second piece. A third piece would be outbreak detection, which is something that's been going on for many years already by analyzing things like search terms and trying to pinpoint where disease is starting to emerge, where certain symptoms that are strange are starting to emerge. Some really interesting stuff going on there, and it has been for a while. I'm happy to talk about. The fourth one would be contact tracing using mobile technology, social media tools. There's been a lot of talk about that out there. And the fifth one, and a really, really important one, is for every single one of us to view ourselves, in a sense, as a white blood cell in this global immune system, which is a term that I'm borrowing from Naval Ravikant, who I know is also going to be interviewed here. Naval and I had a recorded conversation that became a podcast episode, my podcast a little more than a year ago, and I quoted him in my TED Talk as well. The idea of the immune system is like, about being a white blood cell, is like there's 7 billion of us, and very, very, very few of us will want an annihilating epidemic. And so why don't we all marshal ourselves? What can we do? We can certainly lobby our elected leaders to fund and be urgent about the creation of a technological and scientific immune system. But the other thing is that anybody who is pushed to the point of suicide, or much worse, to the point of suicidal mass murder, started out as somebody who was very, very injured in some way. And one of the things that we can do is just make sure nobody goes unloved.
Well, we're absolutely, this is exactly a wonderful way to put a bookend on this conversation. At the Oslo Freedom Forum, we are involved with the survivors of the terror of authoritarianism. And it takes a while to realize that most of the people engaged in authoritarian conduct, in propagating torture, in engaging in purposefully, deliberately causing so much suffering in humanity, are themselves people who have profound emotional injuries, disfiguring emotional blockages that lead them. That's not to say that they shouldn't be held accountable for it and are not guilty of it. But what you're to an authoritarian government at their psychology to harm humanity are people we should not let fall through the cracks.
Yeah, people who would use a gun and perpetrate a mass shooting, a knife and perpetrate a mass stabbing, which happens in some societies that don't have ready access to guns, and certainly in the future, synbio. And what's interesting about this is, if you look at the objective of not letting anybody go unloved, or trying not to, and trying not to let anybody fall through the cracks, if you look at that objective through almost like a beatific, empathetic, loving lens, or you look at it through a pathologically selfish lens and say, I don't want those people to go unloved or fall through the cracks because they might perpetrate an odious act of mass murder. They both lead you to the same point, which is, let's not let people fall through the cracks, and let's do everything we can to prevent that and prevent the sort of early life trauma that can lead to these acts later on.
So that's a beautiful, beautiful post Easter Sunday message. And I thank you, Rob. And we are now going to look at some of the questions asked. I think we have a few minutes to answer some of the questions that we are being asked right now. Wow, the comment section is very lively, very lively. And let's see, we have one from Uana. She's asked several questions. They're very, very good questions. Rob, has there been a discussion on the international or national level to create a system to assure that these potential bioweapons are treated as, say, a weapon of mass destruction, as a WMD?
You know, what we talked about in the interview, and what I've done most of the research on this topic in, has really been much more lone actors rather than state actors. And so, you know, in terms of bioweapon conventions, there's lots of them. And in fact, I believe a very large majority of the more developed nations with the larger militaries have forsworn, at least publicly forsworn, the use of bioweapons. So there's definitely lots of conventions out there. But the type of person that I've been greatly concerned about, that we talked about today, would not be bound by international convention and would not be considered to be a state actor in any sense of it.
Okay, so what follows this is Tom. Tom wants to know, well, if you outlaw synbio, will it not be the case that only outlaws will use synbio? Absolutely.
It would be an incredibly ill-considered plan to try to outlaw it in any way, shape, or form. As I mentioned in the interview, this is technology that can be and is practiced in garages. It's not like a nuclear weapon, which requires the resources of a nation state to create. And so it'd be almost impossible to allow work in this domain. And if you did, you would basically be guaranteeing that the most malevolent people who flout international conventions and aren't bound by the type of morality that prevails in much of the world will be the only people wielding this technology. So it'd be a terrible, terrible public policy decision to outlaw it. Absolutely.
So how do we best protect ourselves? How can we prepare when certain countries have zero transparency?
Well, like I said, I think, the best thing that I can think of, and I've given this a great deal of thought. I've spoken at great length with dozens of scientists in this domain. I've written and spoken about this subject a great deal, and I keep coming back to an agile, rapidly adapting, very robust international immune system of the type that we talked about, that is very robust pathogen detection of the sort that we'll be capable of in several years, not just the relatively primitive stuff we can do today, highly distributed vaccine distribution, outbreak detection, contact tracing. Those pieces coming together could be a very, very robust hardening of the system. Now, going beyond that would probably require pretty intimate knowledge about where a particular threat's coming from and what's constituting. Now you're in the realm of intelligence. And I hope that the world's intelligence organizations are very, very focused on this threat and are very, very watchful about it. Sort of a broad spectrum hardening of global society to this can go a very, very long way and is the best general purpose tool that I can think of.
Uwana has another great question. Let me just highlight it here. Gain of function research and oversight is managed only on a country by country basis. How can the world protect itself against a worst case scenario? And let me just add, the issue of the worst case scenario is coming up more and more in different questions. And it's both, how do we protect ourselves from nation states doing it? And how do we protect ourselves from like terrorist organizations or to use a phrase that is coming up in the comments, Bond villains, that stuff. And then I should also add, I thought this was appropriate. The water I'm drinking is called liquid death. I thought this would be a day to open this, is discussing synth bio with you.
Well, I mean, again, going back to how best to protect ourselves, I'm sorry to sound like a broken record, but I do think developing a very, very robust and agile is a very important word here, immune system that's broad spectrum and has maximal international cooperation. But we know from all of the flouted international norms and treaties going back centuries that no one nation can rely entirely on all other nations adhering to anything. So I think it's definitely incumbent on the United States and on Austria and Australia and every other country that's out there to cooperate with the international community in protecting against this, but not to naively expect that all parties are going to be fully transparent. So, we should, in the United States, just to be a little parochial, because that's where I happen to be, we should absolutely cooperate, encourage, be part of a global effort, but at the same time, be very, very appropriately skeptical about what we hear from different quarters, depending on the credibility of those countries and their track records of being honest brokers when it comes to honoring different treaties and so forth. And definitely beef up our national system as massively as we can, even as we cooperate with the international.
So the repeat questions of what do we do is something that I think you've addressed both on the personal level, what we can do against lone actors, and the issue of depending on states when handling some of this. People keep asking, is this the next form of terrorism? The answer is, I think, yes. You are definitely an authority on this subject. Some people think that because you're just a science fiction writer, that this doesn't mean you're a brilliant researcher that has had one of the most successful TED Talks on the subject of a weapon of this kind. What is your view of the likelihood? This question is from Bob. What is your view of the likelihood of race targeting of a bioweapon, of using symbiotic to go after certain DNA?
Yeah, it would be very difficult to do today, but perhaps not quite impossible. But with an exponential technology, we unfortunately have to presume that which is conceivably doable but hard today is going to be pretty damn easy with frightening rapidity. And so that is a really, really frightening possibility. and in part because of something you mentioned in passing. Is this the next terrorist act? The immediate answer would be no, because terrorists generally are very discriminatory in who they want to target. They want to harm these people, but not those people. And the current pathogens that are out there, certainly COVID, obviously, COVID's an equal opportunity employer for the most part.
Right.
I mean, there are different death rates in different ethnicities, but that may have to do with underlying conditions, denser living conditions, et cetera. But yeah, it would at some point, and probably in the not terribly distant future, be possible to look for biomarkers that are very classic or typical of particular ethnicities and either target them for protection or target genotypes that feature those particular quirks, target them for attack. I mean, that's not something that is inconceivable, and that is something that is all too plausible and probably a high single-digit number.
But arguably, this could be a situation where you could develop a weapon eventually that just targets one person.
Yeah, absolutely. In fact, there was you could. If you had somebody's genomic sequence, that is a possibility. And in fact, it was a really chilling but well-written short story, I believe, in the Atlantic. I want to say about 5 years ago. It was like a short story, and it was very, very speculative at the time, but it was about somebody basically creating a lethal influenza that was specifically targeted to the President of the United States and was unleashed at a convention at which he was speaking, and which in fact killed him by what certainly appeared to be a natural cause. That was science fiction at the time. One of the interesting things about science fiction is it gives our imaginations an ability to exercise that which might be possible in the very, very near future. And in this case, at least two of the authors had a very, very deep knowledge of synthetic biology, and it was speculative fiction, really talking about something that will be entirely possible.
So again, we have a ton of questions for you, and I think one of them that is obvious, given that it would affect all of us unless the weapon was very focused. What's the main objective of biowarfare with a virus?
Well, as we were talking about in the interview, in the case we were talking about in the interview, and what really does continue to worry me the most, somebody who is truly nihilistic and therefore suicidal, and therefore just has, what was the agenda of the Las Vegas shooting? I don't know. He killed 59 people.
Right, to kill
everybody in the world if he wanted to? I don't know. He certainly didn't stop at 59 because he had a moral qualm about killing 60 people. He actually injured over 400 people. The only reason he didn't kill over 400 people was that he failed to kill most of the people that he shot. And so the motivation of somebody who's truly nihilistic is probably unfathomable to most of us, but we've seen enough of them in action to understand what's going on. The motivation of, let's say, a racially based fascist government might be to say, hey, let's target the genotypes that are out there that don't represent us and then have the entire world to ourselves. That would be kind of a crazy thing because supply lines would collapse everywhere. It would be an absolute doomsday for everybody, but people could be deluded to that degree. And the motivations of terrorists, if they had a very specific enemy, had a particular genotype, they might say, we're going to rid the world of this narrow class of people. I mean, these are getting into such deep pathologies. It's hard to speculate, but those are kind of the three flavors that I could think of.
I'll ask another one from the same person. Is it concerning that China owns many of the DNA retail testing companies? Do you think this is a concern? And that opens up the wider question of privacy around, people send their sample DNAs to find out about their ancestry and whatnot. Do you think that there should be a privacy bill regarding genetics and your DNA and privacy of what that means?
Yeah, I mean, first of all, with respect to China owning a lot of DNA testing companies, that doesn't particularly concern me. Most of the DNA sequencing equipment comes from an American company, Illumina. They've practically cornered the market. Anybody who wants to get Illumina machines can get into that business. I'm I wasn't personally aware that Chinese companies owned a preponderance of them. 23andMe is the one that I'm most familiar with. They're definitely a Silicon Valley company, so that doesn't particularly worry me. That is, I wouldn't say that's borderline commoditized product. So that's not alarming, and even if it's the case, it's not alarming. In terms of privacy, yeah, I think genetic privacy is even more important than financial privacy, and the only other forms of privacy that we all wish we had, and we have far, far less of than we probably do wish we had. And it's all the more important with genetic privacy because we don't know what our genomes might reveal to somebody who has access to them in 5 years. Genome sequencing is getting better and better and better with unbelievable speed, but so is the interpretation of that genetic data. And there are going to be things that we can tell from looking at a genome in 5 years that are unfathomable to us now. So there are a couple companies out there that, and I won't name them partly because I'm kind of a little vague on the name of one of them, but they basically say, hey, well, guess what? We're going to sequence your genome for free. And then you can, query it and do this, that, and the other thing. And if you read the teeny tiny fine print, it says, oh, by the way, we got your genome and we get to do what we want with it. Well, what they can do with it is, like, what they'll be able to do with it in 6-7 years, maybe really horrifying. And maybe data you don't want anybody to have on you. So do protect your genetic privacy as an individual. Read that fine print. Yes, we should have laws protecting that.
Yeah, well, I think people sometimes they give up their privacy, not just genetic, but all kinds of privacy when they just sign those terms and conditions without knowing. We have a question from Ravi Mantha from India. Hi, Ravi. Wouldn't a modern day Bond villain who is woke work on fertility damaging viruses rather than those that kill people? I mean, murdering people is so unnecessary to save the planet. This actually kind of reminds me of the plot of Kingsman, the movie, where you have a billionaire villain who wants to wipe out humanity and uses, cell phones, and the movie's got an interesting plot. It's not a synbio, but it definitely has a let's kill as many people as possible vibe to it. So fertility damaging viruses.
Yeah, I mean, when you think of the motivations of somebody who wants to essentially rid the earth of humans, I think of the Vegas shooter. I'll use that as a euphemism.
You think of the what?
The Vegas shooter, the Columbine, like somebody really nihilistic. But another logical category are eco-extremists, people who genuinely think that the world would be a far better place if there were no humans, and have some pseudo-ethical basis for that. And there's something called the voluntary extinction movement, and these are people who basically, I think I got that right, who basically advocate that humans should not reproduce. And it's not too much of a leap to imagine that there might be an involuntary extinction movement at some point that says wipe the slate clean. But with respect to fertility, yeah, it's certainly imaginable that an eco-extremist might be anti-murder and say, let's just sterilize everybody. And that is a plausible vector that next generation engineered pathogens could certainly be capable of achieving. And it's interesting to think about groups that might collaborate on this, because generally speaking, groups are more dangerous than individuals. A group can obviously be in multiple places at once and leverage a diversity of skills that aren't resident in any one person, and have 30 hands to access and manipulate things rather than just 2. And so terrifying as the nihilistic suicidal mass murderer genuinely is, when you start thinking about groups, and extreme eco-terrorists are one group that can conceivably move in this direction, they'll be capable of far greater mayhem far sooner than the lone actor. So yeah, that is something that people should really think about, and policymakers should be thinking about, and counterintelligence groups should be thinking about.
Well, I'm going to ask a couple questions. You've been so generous with your time. I mean, we could just keep going and going. You're so much fun to speak with, Rob. Uwana has another question, and again, it's wonderful to have so many people comment and ask questions. Some are very lively. Here we go. Just as risky as it may sound to advance in genome sequencing, isn't it equally as positive and life-saving. And I think, you know, you've essentially really had a bone-chilling conversation about the use of this and the misuse of this. Now, can you turn this around and tell us the good news about this? And, you know, Cameron earlier had, this is a long time ago, there's like 100 questions back. Is there any good news that we can end on for the day?
Yeah, so that's kind of two different sets of answers, and I'll conflate them. So first of all, I do not want to get lost in this. The fact that synthetic biology is one of the most wonderful and promising technologies that humankind has ever hit upon. The positive potential from this is absolutely boundless. I believe that SynBio is going to help us cure cancer. I think it's going to resolve the organ shortage, people who need organ transplants. I think it's going to do an enormous amount to heal climate damage. I think it's going to enhance longevity. All of these things are unbelievable benefits that humanity should crave and should avail itself of. And I don't want to lose sight of that in all this. Just like commercial planes are generally overwhelmingly positive technology that can, in some narrow cases, be used for horrible, horrible ends. This is another thing that's like this. And I might be repeating something from the interview, but I'll just restate that the crushing majority of people who go into SynBio are good guys. They're wearing white cowboy hats, and they don't want this to happen any more than any of us. In fact, it repels them even more than it does most people, because this is what's sacred to them. And so I think that the right thing is certainly not to ban the technology, not to fear the technology, but to enlist the technology and its exponential thrust to create countermeasures and to enlist some percentage of the intellectual and dollar capital that's going to go into SynBio to create countermeasures, and let the rest of that capital, human and financial capital, to delivering these unbelievable blessings that, you know, a generation or two are going to transform, hence, and hopefully in our own lifetimes, are going to transform human society in spectacular ways we can't even contemplate. Now, that alone, I think, is a good to end on. But in terms of like, are there things to be optimistic about at this moment, this terrible moment in this raging pandemic? Yeah, I mean, I think, you know, I've been watching the IHME models. It's one of many pandemic models that's out there. It gets a lot of press. I forget what it stands for, but IHME. They have been revising many of their forecasts for total death tolls in the diversity of countries, including the United States, downward in recent days. The data seems to be tracking that model. I think that's a really, really positive thing. We do seem to be flattening curves throughout the world. That's not something I expected 10 days ago, and it's something that is in fact the case right now, and that's pretty wonderful. If we have to search for, as we should, silver linings in this horrible thing that's going on right now, I believe one of them is this is a wake-up call we will not ignore. We ignored the SARS wake-up call. In fact, we smashed the alarm clock so hard, we scattered alarm clock guts.
The snooze bar. We smashed the snooze bar.
The snooze bar, I'm sorry. Yes, the snooze bar. I use my iPhone now, so I've forgotten like the very spotty parts of alarm clocks. We smashed that sucker. We ignored that wake-up call. We ignored the MERS wake-up call. We ignored Zika. I don't think we're going to ignore this. And if we do, we do so at our peril.
So this is our dress rehearsal. So this pandemic is our dress rehearsal.
Yes, it is our dress rehearsal. And the second it is over, in fact, hopefully starting already a few weeks ago, we need to get prepared in a very, very serious way for something much, much, much more deadly and much more contagious, because I think it's inevitable that something like that will be unleashed upon us. I don't think there was any public will to do that kind of preparation a year ago when I gave the TED Talk that you mentioned. I think there's a lot of public will to do that sort of thing now. And I'm optimistic that we will. So that's another positive thing to focus on.
Well, again, thank you very much, Rob. This has been a wonderful conversation. Because there were so many questions and some people didn't realize where the ask a question button was, I have to say that you have a lot of admirers and people watching, and the truth is you have a beautiful mind, and I love talking to futurists. I think it's very important for people who are in the human rights field to discuss things with futurists, with people who are essentially building and thinking about a better world, and sometimes thinking about the dark passageways that we can end up in if we're not careful and not vigilant. So again, thank you very much.
Absolutely. Thank you for having me here. It was really very big.